Which speaker should I buy? That's a pretty standard question that buyers of my amplifiers ask. Or, to put it another way, which speaker do you recommend? But again, we have to take another look at me. Since I'm an engineer, I have a pretty narrow specialty, and I'm not a speaker salesman. I can't test a huge number of speakers. Salespeople can do that, so this question should be asked in the store. But I understand why I'm being asked this question. In today's world, marketing works so cleverly that it's very hard to tell what's true and what's just a myth. And in this video, I'll try to give you some theoretical background. I can't tell you which speaker you should buy. You have to go and listen. Here I agree with all the sellers who say that you need to go and listen. But on the other hand, there's a certain theory to it. And if we know this basic theory, we can navigate much better and easily understand where marketing is deceiving us and where we have an honest seller who really wants to sell us good equipment, a good speaker. Who is passionate about this, who understands everything and can give us good advice. And in order for us to resist marketing, we need to learn the theory. Yes, I understand. It's boring. Yes, there are no pretty pictures and there is no easily accessible information. But without theory, it's almost impossible to navigate the modern aggressive world of marketing. And the first concept that we need to understand quite well is baffle compensation, also known as baffle step compensation, BSC. This is an important concept in acoustics and speaker design. It takes into account the change in the frequency response of the speaker or the loudspeaker due to the size of the front panel of the enclosure, the baffle. When the speaker emits sound, it behaves differently at high and low frequencies. High frequencies have a short wavelength. The wavelength is shorter than the front panel, so they are emitted forward because the baffle prevents them from wrapping around. Low frequencies have a long wavelength. At 100 Hz, that's about 3 meters, which means our speaker is much smaller than 3 meters. It freely wraps around the enclosure and radiates in all directions, the so-called 4-pi space. But essentially it's like a sphere. If we look at a speaker, whether it's rectangular or some other shape, it's still like a point source and radiates equally in all directions. Because of the transition from directional to non-directional radiation, the bass level drops by up to 6 decibels, which makes the sound thin and unbalanced. We're talking about sound pressure. And if we remember that sound pressure is logarithmically related to amplifier power, so if it drops by 6 decibels, that's twice. To compensate for this, we need to increase the power fourfold. So if we were listening at 40 watts, now to compensate for those 6 decibels, we need 160 watts. Baffle step compensation corrects this dip. Usually it's done through a passive LR circuit, an inductor plus a resistor, or in active systems it's done with DSP or an equalizer. There, it's all much simpler. How is it calculated? So the frequency where these transition changes begin, from radiating into 4-pi or into half space at 180 degrees, meaning only forward. Here we have a formula, 115 divided by W, where W is the width of the baffle in meters. And here are some classic calculations. Well, 20 centimeters is typical for small floor standing or bookshelf speakers. And we'll recalculate here. So this effect starts for us at around 575 Hz. 30 centimeters is, well, that's about a classic S90. It's a bit wider, yes, that's 383 Hz. And those big classic front panels, I don't know. Early examples were Pioneer and JBL. Some of them had a 40 centimeter front panel, sometimes even more. 288 Hz. Also, if we look at how we can fix this, so if an inductor and a resistor are proposed, this is not very good for a passive crossover that's built into the speaker. additional losses in controlling the low-frequency driver. And this is often solved in the way it was done in the S90. There was a big switch there, and we would just remove the mids and highs, making everything balanced. So what does it look like in the picture? Here I took an ideal case. We have a spherical box, a spherical enclosure. There's a speaker there. It has a front panel. And it turns out that at high frequencies we emit at 180 degrees, only forward and upward. But when the wavelength becomes long, we emit in all directions. And in the anechoic chamber, our sound pressure drops by half. What conclusion can we draw here? If we place the speaker close to the wall, and we get everything back, yes, if it's close to the wall, it means our speaker produces much better bass. In the corner, you even get a boost, but if we move it away from the wall, we lose the bass. And here we have a challenge. Since it's a passive speaker, where the filters are built into the speaker, we can only tune it for one of these situations. If we want to tune the speaker so that it sounds right close to the wall, then in the anechoic chamber, we should see a drop, right here. This is what it looks like in the anechoic chamber. Free space means anechoic chamber. We tune it with this kind of drop. And when we listen in the room, we'll move it close to the wall and compensate for this roll-off. This shape is like this too. It should be like this. So somewhere from these frequencies it starts to rise. It rises like this, more like this, but it's compensated. It turns out to be a perfect and ideal response. But if we have a large room, we move it away from the back wall. Then we set it to 0. And what happens if we move it closer to the wall? We'll have too much bass. It'll boom unpleasantly. So we have two types of speakers. Those that should be placed close to the wall, and those that should work relatively far from the wall in a large room. And as I said, for the S90, this is solved by having a switch like this. -3 decibels, -6 decibels, we lower the mid and high, yes. So we just lower this part, and we end up with a balanced signal again. But we need 4 times more power to drive this speaker compared to when it's placed near a wall. It's important to understand that when we're putting the speaker together, we need to know how it's tuned in an anechoic chamber. Whether it's close to the wall or far from the wall. How else can we solve this problem? You've heard that there are speakers that have what's it called bi-amping. There's this jumper. And the low-frequency filter is separated from the high-frequency filter. Usually, what do those not-so-good salespeople do? They sell you a cable where it's connected on one end, and on the other end you have 2 pairs. That's not what it's for. The sellers are just selling you something you don't need. There are jumpers for that, which we put on this terminal. And we only need one pair of cables. Bi-amping means that you use 2 channels on one speaker, each with its own separate control. And when you place it against the wall with the woofer, you remove the excess. And when we place it far from the wall, we add more. For the woofer, you need a powerful amplifier. I would say if 100 watts is enough near the wall, then away from the wall you need more, 400 in the ideal case. Just because of where you placed it. And if you place it in the corner, on the floor, in the corner, you get an extra effect in return. The English term is room gain for the amplifier. The room gain is about 8 to 12 decibels. We can drive this speaker with a very low-powered amplifier because we have this extra boost that comes from the room. It's important to understand how the physics works. And then we make the right decisions. For those who bought a speaker that's too big for your room, it just means you need to use bi-amping. And then your bass will be perfectly balanced. It will sound great too. The second part, here you see at 100 Hertz, where our main bass is, we have a dip in the room. Let's talk about this. In a room, bass dips occur because of speaker boundary interference response. It's the interference between the direct wave from the speaker and the wave reflected from the wall. Well, since we have the wavelength is long, it's bigger than speaker. So, both forward and backward, we have almost the same sound pressure intensity. If the speaker is placed at a distance d from the wall, the reflected wave travels an additional path and can arrive out of phase, causing a dip. The first and deepest cancellation occurs at, and there's a formula here, it's the speed divided by 4 times the distance from the wall. And we measure from the center of the driver, not from the back of the speaker cabinet, from the center of the driver. For the woofer, it's a bit inside the cabinet. Well, it depends on how the cone is made. And here, calculations have been done. At what distance the woofer is located determines where this dip will occur. The worst dip is somewhere around 100 Hertz, if it happens. Well, if it's 10 centimeters, well, if the speaker is big, there's no way we'll get 10 centimeters. That's a small speaker. 20 centimeters, 30 centimeters. Usually it's about 40 centimeters from the wall if we're trying to place it more or less tightly. So we'll have a dip at 214 Hertz. Yeah, somewhere around there. Somewhere around here on average. And the further we move it away. So at 1 meter, that's bad. That's bad because it hits our bass exactly. All music that has such a clear rhythm, it will suffer. And 1.5 meters isn't very good either. At 50 Hertz, there are a lot of low-frequency instruments. These 2 frequencies aren't very good, so when we try to place something maybe at 50 centimeters, at 40 centimeters, we move it away. If our woofer is exactly at 1 meter, well, then it's a complete mess. What other conclusions can we draw? If we can get pretty close, if the speaker is such that its size allows us to place it close to the wall, and if it has a wide front panel, it might turn out that this effect won't happen at all, because baffle compensation simply won't allow those frequencies, where full compensation is applied, to go backward. It will only radiate forward, and then everything is fine. So, there's a certain compromise here. How do you place the speaker? What are its dimensions and so on? And what does it look like in practice? Here's a diagram. Here we place our speaker. Here we have direct radiation. It starts from a quarter wavelength. Since the loudspeaker moves forward there, that means that's where the maximum is. Sound pressure, and part of it goes backward. And there's a frequency where it cancels out everywhere. If you subtract this from the main one, here we have 0. 0 everywhere. 0, 0, 0. The sum is 0. This is the worst case scenario. And that's why we need to move our speaker and measure this state. And then we know how to properly set it up. Well, the measurement is taken somewhere here at the speaker cone, right? And then from this point we measure to the wall. If we have a large room, the side walls are far away. This influence is very significant. If we have a relatively small room, we have a ceiling, we have a floor, we have walls, then it is less pronounced, since we will get other reflections in a different phase. Here, we get a more or less normal bass. Therefore, in a small room, the bass will be better than in a large one. In a large room, it will depend much more on where we place our particular speaker. There are apartments where the ceiling is high. There it's 3 meters or more. A sound wave weakens in proportion to the square of the distance, so these losses will be very significant for us. And I hope you understand that you can't compensate for this with a tone control or boost this frequency. The more you boost this frequency, the more the reflected sound will be amplified. It will always be cancelled out. Your neighbors will go crazy, but you'll never have any bass. Only the correct placement of the speaker determines whether you'll have proper bass. If you place it completely wrong, the bass will disappear altogether. Seriously, it will be very weak. That's why speaker placement is important. Here's another picture. For example, here you took a bookshelf speaker, built it into the wall, and everything is great, right? Everything is great. But if we attached it to the wall with a bracket or something else, we get a dip. Well, there's about 20 centimeters from the wall to the front panel, so it'll be around 200 or so. That's a serious dip. That's why in studios speakers are never mounted on the walls. They're moved well forward. Then this dip moves down below the playback range, and we place them on a stand close to the mixing console. That's also an important thing. Another important category is the first reflected wave. So we have the direct sound from the speaker, and there's the first one that reflects off the wall, which clearly ruins our soundstage, because all the directionality for a person is determined by the phase difference between one ear and the other. And if we have other signals coming in, they distort it. There can be a lot of these. So, what is the time of the first reflected sound wave? The time of the first reflection is the delay between the direct sound signal that goes from the speaker to the listener, and the first reflected sound, which first hits the wall, floor, ceiling or table, and then reaches the listener. This delay is very short, usually from 2 to 20 milliseconds, but it has a strong effect on sound clarity, soundstage and frequency response. Let's remember here that the first reflected wave within 20 milliseconds is perceived by us as a single sound. This is not an echo, it's a single sound. And how is the first reflection calculated? This is the direct path, speaker to listener. The reflection path, speaker to surface to listener. Well, it's longer, so the reflected one. We subtract the direct path, divide by the speed of sound in open space, in air, and we get the delay time. And these are the typical values for the first reflections. So, well, in a real room, yes, a sidewall reflection is about 3 to 10 milliseconds. We still hear it as a single signal. Ceiling 4 to 12 milliseconds, floor 1 to 5 milliseconds. Speakers are usually closer to the floor. The table in the studio is from half a millisecond to 2 milliseconds, and the back wall is somewhere between 10 and 40 milliseconds, depending on how big the room is. These short delays, less than 20 milliseconds, aren't heard as echo. The brain combines them with the direct sound, which leads to comb filtering, a blurred stereo image, worse localization, and a change in timbre. But what we dislike the most is the blurred stereo image. We want all the instruments to be played back very clearly. Why is this important? If the reflection arrives earlier than 20 milliseconds, it interferes with the direct sound, reduces accuracy, and colors the sound. If the reflection arrives after 20 to 30 milliseconds, the brain perceives it as a pleasant sense of spaciousness, and not as coloration. That's why it's pleasant for us to listen to music in an open space in a room. And we kind of like it a little more than listening with headphones. It's this spaciousness. This added sense of room gives an extra pleasant feeling. And if the reflection comes after 50 milliseconds, then it's an echo. We hear it as a repeated signal. Our brain is very clever. What other conclusion can we draw here? When we measure in an anechoic chamber, we have only one signal. So the amplitude of the sound pressure completely matches what we hear. But when we're in a room, our brain, our auditory system, integrates the direct signal with the reflected one. And that's why what we measure perfectly in an anechoic chamber doesn't always sound pleasant to us in a room. The same goes for a studio. Sometimes the monitoring in a studio isn't very good. They treated the room very aggressively. Yes, it's a measuring tool, but we like it when there's a bit of spaciousness as well. If we balance an untreated room like this and set everything up correctly, it will be extremely pleasant to listen, even better than in a studio. It might be more accurate in the studio, but purely for listening to music, this will be such a comfortable experience. So an untreated room is not necessarily a bad thing. Sometimes you may just need to treat the room a bit. Here's an example calculation. You can go through it yourself, pause it. And what do we get? We get that if we want to listen very well, the most unpleasant thing for us is this first reflection from the side wall. Often it's close, and they're equal in power, but we need to be careful with this panel. Because if this panel absorbs frequencies differently, and usually these panels don't absorb the low frequencies at all, and it starts absorbing somewhere around 500 Hz, so the direct sound ends up being balanced. The highs and lows are reflected. There are a lot of lows. There aren't many highs, so we end up with a muffled sound. We also really need to know how to work with panels and think about whether we need to install them or not. I would say that with proper speaker placement we can do without these panels. And if we put it in the corner, yeah, that's also not a bad spot. But of course the bass will be emphasized, and then bi-amping is almost mandatory. But then our direct and reflected sound will have very little difference. We'll have a good soundstage. Also, when we're choosing a speaker, there are so many methodologies about the speaker, how everything should sound, and a lot of marketing, examples. If you don't have a system for 5,000, 10,000 euros, you have no idea what good sound is. But that's not true. That's not true. You can get good sound for a very reasonable price if you understand the theory. People often write to me in the comments, "What kind of equipment do you have?" You don't have, a $5,000 amplifier. You haven't bought yourself the right to talk about good sound. But people don't understand that if I, as an engineer, know how this works, I would never pay 5,000 for an amplifier, because there's nothing in there worth 5,000 euros. The coolest amplifier can be made for 1,000 euros. So basically, I won't buy such equipment because I wouldn't respect myself. And it's not about the money, it's about self-esteem. I wouldn't respect myself if I fell for such dumb marketing. That doesn't mean that for 5,000 it's bad equipment. No. But in my philosophy, I want to buy the very best for my money. I want to know what I'm getting in return. That's the Pareto principle. 20% of the investment and 80% of the result? Well, in audio, it's 90 to 95% of the result. And a little bit about whether we really need speakers with diamond drivers, or with a beryllium driver, or maybe the most... There was an experiment here with sound engineers. All of them were young, and a lot of different measurements were taken. They listened to different kinds of music. And when many people say that this speaker doesn't sound good, look at what happened. We have the S30 with a subwoofer. Its rated distortion, according to the documentation, is from 3 to 5%. And basically, these young people didn't hear those distortions. So, it's a relatively good speaker. And today, a mid-range speaker for a three-way system? Well, where the distortion is less than 1%, you can buy it for 50 euros. There's the most critical range. There it's about 1%. And inexpensive speakers can sound incredibly good. They don't even hear 3 or 5%. Also, total harmonic distortion, or distortion in general, well, it's a debatable thing. And also, when we choose a speaker, we choose for ourselves, and essentially we need a speaker that awakens this primitive essence inside us. Let's call it a kind of reptile. All of history shows that our civilization hasn't existed for very long. There was a very long period when we sat around the fire, or even without a fire, and we would dance to the drum and howl at the moon together with the wolves. That primitive essence, it's not far away. It's not far away. And music is one of those things that can reach it. This primitive essence allows us to be very happy, to experience good emotions. And your speaker should be such that it reveals your primitive essence, so that it gives you energy. I can say that for work I use bookshelf speakers, professional studio monitors. And right now I'm also recording and listening to everything on studio monitors. But I don't listen to music on studio monitors. I have a big three-way speaker. And with the big speaker, the lower register is very important. It's very important. And it's expensive, yes. That kind of speaker is going to be big. If there's good bass, the speaker can't be small or even relatively small. And when you choose your speaker, think about how you're going to listen. Personally, I only listen to music alone when I listen. In the background, we're there talking with the guys, with guests. Guests come over, we play different music, but then I'm not really listening. But when I do listen, I listen alone. And I choose the repertoire that my inner reptile likes. And it doesn't matter what others say. It's very independent, has tough scales, and doesn't care what others say. That's what I like, and that's what I listen to. There's also another philosophical part to it. Some guys who bought very expensive equipment, I see they have only 100 CDs that they listen to. The rest are poorly recorded. That's not right either. We have to draw the line somewhere. Because there is a lot of good music that may not be recorded so perfectly. Well, for example, you like one piece of music, and suddenly you hear, or this artificial intelligence suggests another piece from Croatia, where there's an incredibly good performer, or from Greece, where a pianist plays beautiful music that you really like. Let's not limit our repertoire just because of some overly high standards for recording. Of course, recording plays a huge role. It plays a huge role, as it's recorded in our studio. But let's not say we won't listen to MP3. MP3 isn't that bad if the first compression is from the original. We can get 95%. We can listen to all of it. This is a philosophical question. Where do we draw the line? If we set the bar too high, there's nothing left to listen to. Choosing speakers based on reviews. There's a specialist, a blogger, who has dedicated his whole life to analyzing different speakers. He has expensive measuring equipment at home. It costs 100,000. He has measured a lot of speakers. But here's the question. Can I recommend a speaker based on measurements? I can't. Basically, I watched all these reviews. I can't decide based on the reviews? Personally, I can't. Even with all my knowledge and theoretical understanding of acoustics, you still have to listen. So this blogger has his own website, where he measured an unimaginable number of different speakers. He's measured almost all of the ones that are actually good. And here you get quite detailed information about these speakers. There's a video and a whole range of measurement data for everyone who likes to measure things. But you don't need to measure it yourself. Someone has already done it. He also has his own channel. On this channel, there are an incredible number of different videos where he talks about these speakers, about these measurements. But what do I think is the most important thing? There is a lot of educational material here that gives an idea about how things work. He explains those broader concepts. Well, yes, it's in English, but with automatic translation you can probably get by. In my personal opinion, this is the best blogger you can find today, who works with the key manufacturers of good speakers. For me, can I choose a speaker based on these reviews? I can't. Basically, I can't. Almost all of them are good. Which one should I choose? It's hard to say. I like these three-way speakers for a room this small. A three-way speaker similar to the S90s or modern S90s or other modern companies that make them. But it's almost perfect if it's made properly. We're at about 95% of the maximum possible. But regarding many of the journals, reviews and so on, what do we see? The modern marketing world has become so strange. Since many people make money from it, they can't say anything really bad. And then they start talking nonsense, I would say. But let's look at two good examples. Tannoy Revolution Signature DC6. So what do they write? As a result, the speaker system delivers a high level of detail, especially at a moderate volume level, and it does this with a pleasant, low level of sound coloration. But at the same time, it has an annoying tendency to sound harsh and aggressive at high volume. But what don't they say? They don't mention the woofer can't handle it. Yes, obviously. The speaker has this and that. The woofer can't handle it. It's not balanced. We can barely listen to it. Here's another example. Klipsch Heresy 4. This is a very good speaker. A horn speaker, a rare speaker. Further listening confirmed the excellent tonal balance, but it seemed that my initial impression of insufficient bass depth was mainly caused by the lack of distortion. The bass is reproduced so cleanly that it seems a bit light, But in reality, what you hear is the absence of second and third harmonic distortion components, which are typical for speaker systems using bass drivers with smaller cones. Well, basically that's complete nonsense. This speaker is tuned differently. It doesn't have that lower register. It's tuned to be placed in a corner. And if you put it in a corner, then that evens out and you get excellent bass. Yes, everything else, the small harmonics, the minor distortions, it's all great. It's just tuned differently. And here are its characteristics, as you can see. At 100 Hz, there's a good punch. But if you put it in the corner, we get a corner on the floor. We get about 8 to 12 decibels of boost in a small room due to reflections. And then, because of the wide front panel, somewhere around here, all of this will be boosted. So, starting from around 200 Hz, we have what's called compensation. So, there it's 6 decibels, right? And somewhere here we'll get this kind of an additional boost. Yes, of course, it will drop off here, but it will sound great somewhere, up to 50 even lower, almost down to 40 Hz it will reproduce. This will be an amazing speaker. And if we place it and move it away from the wall, according to the theory we've studied, it will sound flat. That's what he's trying to say in his review, that it doesn't sound flat. No, it does sound flat. It's designed to be placed in a corner. It's not 6 but 8 to 12. So we get this kind of boost there. And then this part over there lasts longer. Well, overall, what can I say? Bloggers could have explained it properly. But no, they just talk nonsense. And if you have a small room and you can only put it in the corner, it's an excellent speaker. This is also important when choosing which one we pick. Here is another speaker. This is JBL, a classic one, S90, modern. It will sound very, very good with rhythmic music, but it's designed to stand a little further from the corner, maybe closer to the wall, but it will have that more pronounced bass. Disco will sound amazing. Also, when we watch reviews, they measure something. Everyone talks loudly, but in fact it's not clear how it actually sounds. It's not clear. In general, all these irregularities in the modern world can also be corrected with a digital signal processor, on a digital level if necessary. But overall, these speakers sound good. They worked on them for a long time, finally got them right, and there's a certain compromise there. But if someone doesn't like it, you can turn it down a little. But here you also need to consider, when we're working in an untreated room, how the reflections behave. Maybe some of these peaks and dips aren't even audible. They're compensated by the reflections. Because the higher frequencies get dampened a bit more, and the lower ones reflect off the wall. Maybe all this compensation is happening here, but it's hard to say. You need to listen in the room. Well, it's the older brother of the same speaker, but everything is done properly here. Put it against the wall for a large room, and that's it. You'll get full compensation, and it will sound great. Well, the previous speaker costs about 3,000 euros per pair. This one costs almost 6,000 per pair. But it's much bigger. This kind of bass extension comes at a high price. Good bass response. Here, the lows are really good, everyone says. Users say, it's damn good. When we talk about whether a speaker is good or not, Paul Klipsch, the founder of Klipsch, basically defined the key parameters of a good speaker. And let's see what he said. He said there are 4 main criteria for a good speaker. Well, the first is high efficiency and low distortion. That means we can drive this speaker with small amplifiers. The speaker will always be quite large. This parameter is hard to achieve. Efficiency and low distortion also exclude each other. If we want to control the speaker very precisely, then we need a stiff suspension, which means using large loudspeakers. The second is directivity. In an untreated room, it's ideal. If we use a horn speaker that controls the direction of the sound waves, then we end up with very few noticeable reflections. Or they're far away, and we'll have perfect stereo sound and everything will be just right. How do you do that? Yes, horn speakers. There aren't many horn speakers, and it's hard to make them properly. A high dynamic range. Well, any bookshelf speaker fails right away. It's designed for a distance of 1 meter and doesn't project beyond that. Its low-frequency driver's headroom runs out quickly. We get a lot of distortion. So for listening, a bookshelf speaker can work up to 1 meter. Basically, these are studio monitors, and that's how we use them. There's no point in buying a bookshelf speaker for a large room. And a flat frequency response. Everyone talks about it, everyone measures it. There are completely opposite opinions about it. Everyone shows their own little detail there, whether it matters or not. But in principle, a linear frequency response is important. But I would say plus or minus 2 decibels is ideal. Yeah, plus or minus 3 is also fine. So in this regard, it's easily achieved today. These 3 are difficult and expensive. These are easy, and that's what marketing says. One more important note. Somewhere around 1990, they started making these tower speakers. And from an acoustic point of view, this is not an optimal solution. Basically, they make these tower speakers, add a lot of partitions, and then pack them with various absorbing materials. And still, there are various resonances present. But there's another approach. You can use what's called the golden ratio, where the proportions of the structure are such that you have only one resonant frequency at each value, at each length, at each dimension. It's called the golden ratio. And if you make a speaker like that, you only need a little bit of damping. It sounds very good, there are few resonances, and even then, very little affects it. Basically, we can choose either the proper design or this one, and then try to damp it any which way. This has one advantage. When we need to move these walls back and get plus 6 decibels, we can add a second speaker. Yes, its design allows for that. And there are quite a lot of such speakers. We can also make what's called a 2.5-way speaker. But that's not the case here, where we have 2 woofers, one of which also works on mid-frequencies, and 1 tweeter. But for me, that's a compromise. Yes, it's a compromise. Here, it's all about the design. This is a bookshelf speaker, a near-field monitor. And usually there's a 6.5-inch woofer and a tweeter. It works fine up to 1 meter. Great music, great soundstage, everything, a well-tuned design. A 2-way speaker has a simple passive crossover. And these speakers are inexpensive and work well, but only up to 1 meter of listening distance. Well, there are bigger ones too. But what's the problem when we have bigger ones? When we use an 8-inch speaker, we get directionality, and we have to install the tweeter in a horn. Then it was perfect. Their directivity pattern gets corrected and becomes consistent. In this case, right here on the crossover, it's somewhere around 1.5 kilohertz. The sound to the sides doesn't match the direct sound. But if the room is large and the side walls are far away, this kind also works fine. But overall, I prefer the 3-way. It's kind of shifted upwards. It works up to about 40, that's the optimal solution. And it works all the way down to 25 or 30 hertz, if it's done right. The dimensions are large and the price is high. But this is the kind of optimal speaker where there are practically no compromises. But there might be phase linearity issues. We can say that the center of one speaker and the other do not coincide. But overall, in an untreated room, it's not that important. In a studio, it would matter. And here are all the speaker architectures and crossover recommendations. 2-way speakers. 3-way speakers, where the spectrum is shifted upwards. The low end works down to 40. That's the topic, and the mid-range is small. Here is the optimal speaker, a good 8-inch subwoofer, 4-inch mid-range, and about 2.5-inch tweeter. This is a very common design. Sounds great. I like it too. And there are no compromises here. Here the subwoofer might be bigger, like 10, even 12 inches. Here it's a 5.5-inch mid-range, and the tweeter. Then you have a balanced, good system. What we saw here, this one, this is the big one, the last one. Here are all the architectures. What about those who want super sound? Let's see where we have problems with the sound. Because of the passive crossover, we practically have no way to control the mid-range. It's only controlled by the suspension. We have little electrical control over it. The damping factor here is one resistor, another resistor, and there are some additional components as well. The damping factor there is 1.5. It's small. Basically, we control only pretty much just the suspension. So you need a very good loudspeaker. And for the high frequencies, we also put a resistor, but for the highs, everything is controlled only by the suspension. And when we remove this passive crossover, passive filter, and connect the amplifier directly, we get additional electrical control. And even such a mediocre loudspeaker starts reproducing detail well. Here's one amplifier, another, and all of this gets thrown out. The filter is placed before the amplifier. It's an active three-way system. Then we drive them at a completely different level. So for those who want the very best, we make an active speaker, then we make it active. This is the next level, the next step. Another good specialist. He builds studios and has quite a lot of educational material. I recommend listening to him sometimes. A lot of the myths salespeople tell us about how and where to place things disappear here. And finally, before buying speakers, we really should evaluate how we listen to music. Do we listen when no one is around, but really listen, or do we listen in a group? This means that we can just pick a single spot in an untreated room where everything sounds good. We can also put our speakers on wheels, so that when we have background listening, they can be placed somewhere in the corner. When we want to listen to the very best sound, we roll them out to the listening position. If there are small children, they'll race them around, which is risky, but for those without small kids or whose kids are grown, it's a good solution. We realistically assess where we place the speakers, and where is the best place to put them. There are a lot of recommendations. This could even be a separate video. I won't touch on this topic here. But maybe we don't do any acoustic treatment in the room, but we can rearrange the furniture so that it's more or less suited for good sound. And in that case, the room stays the same, everything stays, the living room stays, and we just come to an agreement with a wife and rearrange the furniture. That's also not a bad solution. Sometimes it really helps with listening to music. Well, of course, there's also the budget we're working with. I can say right away that you can't buy a new one for less than €1,000. No way. You can buy good speakers, well, for about €2,000 new. But there's the secondary market, and there are endless possibilities there, depending on what you come across. Well, I don't know who to believe. You need to go and listen. You need to learn the theory, and then you'll simply understand how it works. And many things will just be easier to evaluate. Regarding speakers, well, you really need to listen. You really need to listen. And here I agree with audiophiles and the most hardcore audiophiles. Basically, you need to listen, and you need to understand how it will sound at your place when you listen. In the showroom or somewhere else. Understand this theory that I'm explaining, and you'll understand how it will work at home. And a lot of things we can solve with bi-amping. Yes, instead of a stereo amplifier, you'll have a quad amplifier or two amplifiers there. So what can we save on if we really have limited resources? We can upgrade old solutions. Well, my main client is the so-called do-it-yourselfer, those who like to tinker and learn. Then, just by replacing the mid-range and high-frequency ones, we can achieve an incredibly good result. Modern mid-range and high-frequency speakers are good speakers, very good ones. Well, active speakers too, that's the next step. We can convert the existing speakers into active ones, and it will really sound better. And the last, most complex and expensive, are horn solutions, which very few people make. But the Klipsch Heritage series, there are three options. They developed them for a very long time. It's complicated. But if it works out, there are a lot of enthusiastic reviews about these speakers. The cheapest ones are 3,000 euros, and basically they don't appear on the open market or the secondary market. Whoever bought them is happy. For myself, I think if there was something I couldn't do, then I would also go for this horn solution. I think it would be better than the others. Maybe not as precise, but this microdynamics, how the compression drivers work. You have to keep in mind that a regular speaker has an efficiency of about 1%, while compression drivers are around 30%. The sound is created differently there, and the directionality in an untreated room also plays a serious role. But that's not for everyone, not for everyone. If given the chance, I would listen. And once again, let's go back to these key principles. High efficiency, low distortion. Today's loudspeakers are mid-range with less than 1% distortion. They make them. Such excellent loudspeakers cost 50 euros. Directivity is complicated and expensive. Dynamic range, a small speaker isn't suitable. You need a big one, which is also complicated. Flat frequency response is easy. All marketing is about flat frequency response. Everyone measures flat frequency response. And all these key things, they don't talk about them because it's complicated, expensive, and hard to sell. Many speakers are immediately ruled out because they're judged by these three parameters, but here everything qualifies. Today's marketing works here. And personally, what caught my attention? Yes, Klipsch caught my attention. A small room in the corner. It's going to be hard to beat. A budget model, three-way. Linton measures perfectly, sounds great, and the basic model with an 8-inch speaker can handle about 200 watts. It costs about 1,000 to 1,200. You can buy it at our store. It's a budget option, but a decent one. Of course, everything is made in China, designed in England, but everything is assembled in China. For this price, you can't do it any other way. Don't believe this. I recalculated it. This parameter is incorrect. It's about 33 to 35 liters or so. How everything is made there. That's the minimum requirements, but nothing more. With speakers, it's not that simple. And here it has three sibling models, each marketed differently, yes. The lowest one, well, you can buy it for 1,000 now. This one costs 1,000 more. It's made a little bit bigger. It might get some cosmetic fixes, a crossover. And then, when we do everything honestly, we have 7,000 there. But this is a straightforward speaker that can handle everything. But in general, there is no simple answer as to which speaker to choose. A really good one costs a lot. The choice is limitless. We go, we look, we listen, and so on. And why am I showing these speakers? Because this floor-standing version is derived from this speaker. If we put another loudspeaker, well, then we'll have a cabinet all the way to the bottom. This is the main structure, this is the main structure. And if you have unlimited space and resources, yeah, this is also a worthy speaker. A wide front panel, a large driver, everything is reproduced faithfully there. High-end speakers are good, but overrated. For those who want to do it themselves, who say, I want to do it myself, but still want it to sound good. There's a good website here. It's Troels Graveson, a Danish, I don't even know what to call him exactly. Calling him a developer would be too much. Well, basically, he has designed speaker systems that sound good using almost all expensive loudspeakers. And if you have enough knowledge to replace some very expensive things with more reasonable ones, there are blueprints here and you can make many things yourself. I'll show you one design that I also made. Here it is. I took this as a basis, but since I had more limited woodworking capabilities, I simplified the design and also replaced the mid-range and tweeter speakers with slightly different ones. Basically 50 here and 50 here. But I kept the main woofer from the Satori series. It's a very good speaker. And let's look at the specs of this speaker, because the bass turned out incredibly good. Yes, incredibly good. So what else? Here, the mid-range drivers are very expensive. As I said, I replaced them with more affordable ones. The crossover, well, as you can see, is pretty simple, but Trolls doesn't provide the crossover components. You must calculate them yourself or purchase them from him, as that's his business. But he does provide all the geometry, all the dimensions, and if you have woodworking skills, you can make this kind of speaker. I simplified it. I don't have that middle large panel, just one panel here and a box on it. He has a different design, a bit more complicated, but it all works just the same. And also I recalculated the port for another one. I took this 70mm sewer pipe and recalculated it for that. It also works well. Then you get this port too, otherwise you have to look for it somewhere and it's hard to find. All these calculations are not difficult, but of course the first time you need to learn a bit. But the speaker sounds amazing. Yes, amazing. I have a video on my website where I assemble them on a CNC machine, on a computer-controlled machine. Where can you buy loudspeakers? There's a European seller, has a wide range of products. I mostly buy here. Here, for example, this average one. I replaced the expensive one with this, and it sounds amazing. If you look at the specs, it's fantastic, yeah. Look at how linear the whole range is. There's a little dip of 2 decibels, just a bit, but overall you don't really notice it. And it plays perfectly, almost up to 4 kilohertz there. And indeed, the accuracy of sound reproduction is incredible. Distortion is very low. And also what I mentioned about active systems. Just imagine, you cut it somewhere at 300, right? Here at 300 hertz, and you cut it at 2.5 or 3.5. Look, it's such a simple load for the amplifier, right? There, the TPA 3255 will perform amazingly. In general, there are many options for good speaker systems that we can make. And I promise to show you this low-frequency one as well. Here are these 2 speakers, a 4-ohm and an 8-ohm one. I chose the 8-ohm one. And the 8-ohm one, well, it sounds incredibly good when people come and listen to the amplifiers sometimes. How it plays, it's unbelievable. It has a rubber suspension. It shouldn't be able to play like that. No, it's just all done properly. The Danes are skilled manufacturers. The developers have a very serious background, and I think they manufacture somewhere in Malaysia. And look, see how it works, how good the lows are, right? At these low frequencies, with such a low resonance, playback drops off very little. That's why the bass here is excellent, and the linearity allows you to build a 2-way system. But this is a subwoofer. Almost up to 2. It starts to break up somewhere around 2, 2.5. Can you imagine? But it costs twice as much as the others. But it's worth it. Well, in conclusion, for those who want the best and at a reasonable price, we build it ourselves. For about €1,000, you can build an incredibly good speaker. An incredibly good one.